Another mixture problem with percentages, but set up in a little bit of a different way. And this problem is actually from your test. If you still have your Chapter 1 test, you should go get it, take it out and look on. Compare your answer to the method that we use here, because I'm going to use exactly the same question. It's about the USDA regulations about what constitutes as organic. So I'll read it first. USDA regulations state that in order for a product to be advertised as made from organic materials, it must be at least 70% organic. So we know we have a goal. 70% organic. An orchard owner grows both organic and non-organic apples. He has a 1,000-gallon tank that is filled with 50% organic cider. So 1,000 gallons. That is 50% organic. How much would he have to drain away and replace with 100% organic cider to meet the minimum requirement? So, how much needs to be drained and replaced with 100% organic? 100% organic to meet the goal. So, I'm going to do this using the second method so we can practice that. We want to think in terms of what percent of what we have is actually made from organic stuff. And again, organic is just another word like saline or acid that we'll be kind of using here. So then how much organic cider is in that? Because that's after all what we're talking about here. We're talking about cider. It would be 50% of 1,000. So 500 gallons. But I'll write it out as 0.5 times 1,000 first. Now, this is a little bit more tricky because what we're doing is we're actually going to be draining some of that and replacing it with 100% organic. So I'm not ultimately going to be keeping all of this 1,000 gallons. I'm going to be taking some of it away. How much? We don't know. So we're going to have to call it X. We know that it's not going to be exactly the 1,000. We're not going to keep the 1,000, all 1,000 gallons of the 50%. So it's going to be 50% of whatever we drain away, or whatever is left after we drain stuff away. So 50% of 1,000 minus X. Whatever X is, that's how much we have to drain away. 50% of that is organic. We're going to be adding to that exactly as much, because we're just replacing it, with 100% organic. So 100% is just 1x. Equals, and I have my third beaker here, I want something that's 70% organic. And exactly how much will be left? We drain away X, then we replace it with X. So my goal is actually to end up with exactly 1,000 gallons still. 70% of which would be 0.7 times 1,000. The tricky bit here is the idea of getting these amounts. And really, in general, for any mixture problem, it's going to be getting these amounts. So you got to think about what is it that you're actually doing. In the previous example, we had a beaker that had space left in it. We were just pouring more on top of it. So it was 8, and then we're just adding on to it. In this case, we can think of this 1,000-gallon tank as being completely full. We can't just add to it because then it'll overflow. So whatever we want to add, we first have to drain away to make room for it. So we're draining away some of the 50%, and we're adding on top of that the 100%. So this is my equation then, 0.5 times 1,000 minus X, or 500 minus 0.5X, plus 1X, or just X, equals 0.7 times 1,000, or 700. Now this, I can just combine like terms. 0.5, or minus 0.5 plus X is 0.5x. So that gives me 500 plus 0.5x equals 700. Minus the 500 from both sides to get 0.5x equals 200. Divide both sides by 0.5, and I get that x equals 400 gallons. So we would have to drain away 400 gallons from this tank of 50% organic cider and replace it with 400 gallons of 100% organic cider in order to get that 70% organic. We can do the mixture picture. I'm going to go off the screen. 70%, and this way I have 100%. On that side, that's a distance of 0.3, and there's X number of gallons of that. That's what I don't know. On this side, I have, 50%, 50%. It's a distance of 0.2. That's 1,000 minus X. So 0.2 of 1,000 minus X equals 0.3 of X. 200 minus 0.2x equals 0.3x. Add 0.2x to both sides, you get 200 equals 0.5x. And then that's the same thing as what we have over there. So you see that this method does eventually get you to the same answer, and in fact it really gets there by almost the exact same method. It's just a different way to approach the problem. So go with whatever way makes sense to you. Ultimately, the method that you use doesn't really matter. If you use the balance mixture picture, or if you find an equation that actually refers to the amount of organic cider in the question, as opposed to the non-organic more watery stuff. Either way, you'll get to the same answer.